Hi, welcome back. This is Professor Ridge, and today's lesson is on Section 8.6, Combinatorics, Combinations. A combination containing k objects chosen from a set of n objects, k is less than or equal to n, is denoted using combination notation n, c, k. So those are subscripts, so I would read these read as n choose k. Okay, so that's NCK, the n choose k. Now, one thing to note too is for combinations, the order doesn't matter. And in permutation, the order matters. So if I said choose 3 objects, okay, so if I said choose 3 objects from the set of 5 objects, objects being letters in this case, A, B, C, D, E, then one combination could be A, B, C. Right? That would be the same as B, A, C, or B, C, A, or right, any permutation. So these are permutations. And this ABC, it doesn't matter what order you write it, ABC, BAC, CAB, whatever, that's going to be a combination. So you just one represent of all 3 letters. Okay, so this would be 5 choose 3. So you've got ABC, ABD, ABE, and then B, C, D, B, D, E, and then C, D, E, and then I'll write the rest. Okay, so there's just 10 combinations picking 3 letters out of the 5. So again, this would be 5 choose 3. Okay, so the total number of combinations of n objects taken k at a time, denoted NCK or n choose k, is given by, so here's the formula, so NCK or n choose k, that's what I said, n choose k, equals n factorial over k factorial times n minus k factorial. Okay, the book is an alternate one, but this is all you need to know is that one. Okay, and we can also call it using a binomial coefficient notation. So we write it in parentheses n over k. So you can read it the same way, n choose k. So that notation with the parentheses, and notice there's no bar or nothing, it's just n over k, kind of like a matrice almost. That's n choose k, same thing, but it's called the binomial coefficient, which we'll talk about later. Okay, let's evaluate 6 choose 4. So remember, it's 6 factorial over 4 factorial, 6 minus 4 factorial. So you get 6 factorial over 4 factorial, 2 factorial. And then I'm going to go 6 times 5. Now I always stop at the bigger one. So 4 factorial, and those cancel out. So I'm going to get 6 times 5 over 2 times 1, and then punch it in my calculator. Now, quite a few scientific calculators have a button for 6 choose 4. So you're welcome to use that. There's how you do it by hand. For small numbers, it's fine by hand. These get large pretty quickly, so you need to make sure your calculator can do these. Okay, so we're going to do 8 choose 3, so 8 factorial, or 3 factorial, 8 minus 3 factorial. Normally I would just write 5. And the thing that I want you to note too is, right, that both these ones on the bottom when you're doing the choose, the combinations, 3 plus 5 is 8. So they always add up to the top number. Alright, so again I'm going to go 8 times 7 times 6 times 5 factorial and stop. That's the bigger one. And that's going to cancel the 5 factorial on the bottom. And then I can go the 3 times 2 is 6, cancels at 6, so I get 56. Okay, so we're going to do 52 choose 5. So it's the same thing, it's just the other notation. So I'm going to go 52 factorial over 5 factorial. 52 minus 5 is 47 factorial. So I'm going to go 52 times 51 times 50 times 49 times 48. Then the 47 factorial, we'll cancel the 47 on the bottom. 47 factorial, I mean. That cancels. And then I got 5 times 4 times 3 times 2 times 1. Punch that all in my calculator, and I should get 2,598,960. Okay, so something to note is if we talk about subsets of size k and of size n minus k, n choose k is equal to n choose n minus k. And it doesn't matter which notation you use. Okay, so again, if we did 8 choose 3, we're going to get 8 factorial over 3 factorial, 8 minus 3 factorial, which equals 8 factorial, 3 factorial, 5 factorial. I'm going to stop there for a moment. 8, now b, if I do 8 choose 5, you can see that, well, that's going to be 8 factorial over 5 factorial, 8 minus 5 factorial, which equals 8 factorial over 5 factorial, 3 factorial, which obviously, because multiplication is commutative, 5 factorial times 3 factorial on the denominator is the same as 3 factorial times 5 factorial. So both A and B give you the same answer. And we did it as B up above, so that's going to get us 56 for both these. Okay, suppose the Senate of the United States consists of 58 Democrats and 42 Republicans. How many committees can be formed consisting of 6 Democrats and 4 Republicans? So you can kind of do this, think of this as 2 distinct processes. Out of the 58 Democrats, choose 6 of them, and then out of the 42 Republicans, choose 4 of them, and then by the fundamental counting principle, we just multiply these 2 numbers. Okay, so that's going to give us a fairly large number. Let's see, 58 choose 6. Oops. Okay, so you'll get about 4.53 trillion times, okay, that's not 10 to the 12, which is trillion. Okay, so how many 5-card poker hands are possible with a 52-card deck? So this is going to be 52 choose 5. So we're going to get 52. Alright, so you get again, it's 52, choose 5, so it's 52 factorial over 5 factorial times 47 factorial, and you get 2,598,960. Okay, so that's all the possible 5-card combinations of a 52-card deck. Alright, so that concludes the lesson for 8.6. Go to my math lab and complete your exercise there, and see you next time.